Welcome back to our third revision session on IGCSE Math 0580 Extended. Today we'll be doing Unit 3 Coordinates. To start coordinates, you need to know the two-dimension coordinates plane. Similar to a number line, a coordinate plane has numbers marked on it, both positive and negative. You can see here, 5, 10, -5, -10. Well, a thing different from a number line is that it's in two dimensions. It has two lines, which is called the x-axis and y-axis. So when you define a point on a two-dimensional coordinate plane, for example here, the x value is 5 and the y value is 5. So it would be something like this, 5, 5 in brackets. The first number will be the x value and the second number will be the y value. For example, a point here would be 1, 1. A point here would be -5, -3. And a point here, for example, would be -3 and 8. And starting from the origin at 0, a two-dimensional coordinate plane is divided into 4 quadrants. This is the first quadrant, this is the second quadrant, this is the third quadrant, and this is the fourth quadrant. In the first quadrant, all the numbers are positive, positive x, positive y. On the second quadrant, the x values are negative, negative x, positive y. On the third quadrant, both values are negative, negative x, negative y. And on the fourth quadrant, the y value is negative, positive x, negative y. And one thing you need to know is that 0 here, the value is 0, 0, and is also called the origin. Now, linear graphs. Linear graphs is the most simple graphs. A linear graph, as the name states, just a line. And we need to know how to graph linear graphs on a 2D coordinate system. So looking at the first example, y equals -2x plus 5. This is in the slope-intercept form, where y equals mx plus c, and m is the gradient, and c is the y-intercept. Now you may ask, what is a y-intercept or an x-intercept? A y-intercept is the point where a line touches the y-axis. This is the y-intercept. And where it touches the x-axis is the x-intercept. And the gradient here, as we've talked about in Unit 2, is the rate of change of y due to x. So it's also delta y over delta x. For example, here, the graph looks something like this. First, we find the y-intercept, 5. Positive 5 is here, mark the point. Then -2, it's the gradient. Negative is going downwards like this. So every x value, y value goes down by 2. So every x value, y goes down by 2. Another point is here. Every x value, y goes down by 2. Another point would be here. And the line will be something like this. And now moving on to the second example. Second example, y equals 7 minus 4x. It's still in the y-intercept form, but reversed. So it is now y equals c plus mx. So we know that m, the gradient, is -4, and c, the y-intercept, is 7. So to plot this, we first find the y-intercept, 7, which is here. Then the gradient is -4, so for every x value, y decreased by 4. Every x value, 1, 2, 3, 4, here. Every x value, 1, 2, 3, 4, here. It will go on forever. So the graph would be something like this. Now moving on to the third example. This is not the gradient intercept form, but in order to draw it easily, we can always change the form into a form that we know. For example, the slope-intercept form, which is the simplest. So we'll make y the subject. Remember from Unit 2? First move x, it becomes negative 3x plus 5. Then we divide by 2. We got y equals negative 3 over 2x plus 5 over 2. So this is the y-intercept, and this is the slope. Here, this is the y-intercept, 5 over 2. And for every 2x, remember, delta y over delta x. So every 2x, y goes down by 3. Y decrease by 3. So we got 1, 2, y decrease, 1, 2, 3 here. Remember, the first y value starts at the half. So next, 1, 2, decrease by 3, 1, 2, 3. So here we got 2 points, 3 points, and we line them up. So the graph would be something like this. So different forms of a linear graph. We've already seen the slope-intercept form, y equals mx plus c. There's also point-slope form, y minus y1 equals m times x minus x1, where there's a point given, x1, comma, y1. And last, there's standard form, where it's ax plus by equals c, where a, b, c are constants. So we can always alter these two into slope-intercept form, which is better for us to draw. For example, we have y minus 3 equals 4x minus 2, where the point is 2, comma 3. We can make this first, we times out the 4. We get y minus 3 equals 4x minus 8, then we plus 3. We'll get y equals 4x minus 5. So it will be something like this. And ax plus by plus c, we've already seen it. For example, negative 4x plus 2y equals 6. We move x on the other side, we'll get 2y equals 4x plus divide by y equals 2x plus 3. Something like that. Now, what if we're given 2 points and we want to know the gradient? For example, a line like this, and we want to know the gradient of this line, m of this line. What we do is we first take 2 points, better be integer points, for example, this one and this one. So here is 1, 2, this is 1, 2, and this one is 4, 8. So we already know that m, the gradient, equals change in y over change in x. So we can just count. We form a triangle. And the change in x here is 3. And the change in y here is 6. So m equals 6 over 3, which is 2. Well, what if we're just given points? For example, we're given 1, 2, and 4, 8. And we want to know the gradient. So what we do is we pick 1 point and we minus the other point. So an equation would be y1 minus y2 over x1 minus x2. The 1 and 2 can be reversed, but just remember, if we are minusing 1 by 2, all would be minusing 1 by 2. So here would be 2 minus 8 over 1 minus 4, which is negative 6 over negative 3, which is 2. Pretty easy. Now sometimes you could be asked, like, given 2 points, and find the equation of a line passing through it. Find the equation of a line passing through them. H passing through them. For example, we have negative 4, positive 3, and 8, negative 9. So we know that the easiest form is y equals mx plus c. So we first find m. M equals change in y that we're changing x. which is -9 minus 3 over 8 minus -4. The numerator will give us -12, and the denominator will give us +12, which is -1. So m equals -1. We already got y equals -x plus c. Now we want to know c. So we just plug in one group of value. So we'll have 3 equals -4 plus c. Thus c equals -1. So we'll get y equals -x minus 1. So it will be something like this. It's not in ratio and the points are not lined up, but something like this. Well, what if it wants us give it in standard form? We know that standard form, y and x are on one side and all the constants are integers. So we just move x to the left side, we'll get x plus y equals -1, and that's it. What if they want it in, let's say, point slope form? Point slope form, then we'll have y plus 4, because minus -4, equals -x minus 3. Okay, moving on. Length. To find a length of between two given points, for example, 35, 3, 5, and 0, -5, we could use the most simple Pythagorean theorem. We construct the triangle, and we know that this is C, A, B, and we know that A squared plus B squared equals C squared. So we find the length of B. Here is 3. So length of B equals 3 minus -5, which is 8. Length of A here is 5, here is 0. We'll have 5 minus 0, which is 5. And C equals square root 5 squared plus 8 squared. Sorry, the numbers aren't that good. C would be square root 89. So a common formula for length of x1, comma y1, sorry, and x2, comma y2 would be square root x1 minus x2 squared plus y1 minus y2 squared. Well, remember, this is only applicable when the equation is linear. If it's like cubic or quadratic, the length won't be just a triangle. This is not equal to this, alright? Midpoints. Similar to length, midpoint between 2 points. For example, here, this is 1, 6, and here, this is -6, -2. Midpoint is the point where the distance here equals the distance here. This is equal. Sorry, it should be here. This is equal. And how to do this? It's pretty easy. So we can see it separately by the y and the x. So y, the first value is 6. The second value is -2. The midpoint between these, thus the average, is 2. Because -2 plus 4 is 2, and 6 minus 4 is also 2. Let's just plus them and divide by 2. And for x, the first value 1, the second value -6. The midpoint will be -2.5. Because -6 adding 3.5 is -2.5, and -2.5 adding 3.5 is 1. So their midpoint will be already seen here, 2 and -2.5. So midpoint formula, midpoint of x1, y1, and x2, y2 would be x1 plus x2 over 2, comma y1 plus y2 over 2. Now parallel lines. We already have the line here, y equals 4x minus 1. And here the point 1, -3. We want a line that's parallel to y equals 4x minus 1 and passing through the point y, comma, -3. So first we need to know what is parallel. We know that parallel are two lines that never intersects. This means that they have the same gradient. This is m1, this is m2. So for L1 parallel to L2, m1 equals m2. Thus, in here, we know that if this is y1, our line y2 here would have the same gradient as y1, which is 4. So we know it's in some kind of 4x plus c. This is where our given point is used. We know that y equals 4x plus c, and we know that when x is 1, y is -3. So we'll have -3 equals 4 times 1 plus c. Thus, c equals -7. So this would be a line looking like this, passing through -7. Sorry for my drawing. This is pretty hard. Remember to use a ruler, okay? And what if, you may ask, what if the line is straight vertical? For example, this is the line of x equals -5. Now, what is the gradient of this? The gradient of this, so we can think it as changing y over changing x. Y is always changing, but x is not changing. So changing y is infinite, and changing x is 0. So this is not defined, just for now. What if it's a horizontal line? For example, this is the line of y equals 5. Then what is the gradient? So changing y over changing x. And we know that changing y is 0 and changing x is infinite. So the gradient is just 0. Now move on to last, we have perpendicular lines. Here's the line of 2y equals 3x plus 1. And we know that in slope-intercept form, this would be y equals 3 over 2x plus 1. For a line to be perpendicular, this is L1, this is L2. Just remember that M1 times M2 equals -1. So M2 equals -1 over M1, or M1 equals -1 over M2. So we already have the gradient for L1 is 3 over 2. The gradient for L2, m equals 3 over 2. The gradient for L2 would be -2 over 3, the negative reciprocal. If we're given like something like passes through x, y, something like that, we can just plug in the value and calculate c. But for this question, we only need to know the gradient. So the gradient of a line perpendicular is -2 over 3. Would be something like this. Y equals -2 over 3x. Let's say minus 1 over 3. Now move on to the second question. Find the equation of the perpendicular bisector of the line joining points -3, 8, and 9, -2. So first you need to know what is perpendicular bisector. So for a line segment, which is a line that has ends, definite ends, a perpendicular bisector is their midpoint, a line perpendicular to the target line and passes through their midpoint. This is the midpoint. So this is combined with our previous page midpoints. So to calculate the midpoint, we can just use the formula. We plus and divide. So the midpoint is 9 plus -3 divided by 2 is 3. 8 plus -2 divided by 2 is also 3. 3, 3 is our midpoint. And we want a line perpendicular here. So we first have to know the gradient of this line passing through the 2 points. Changing y over changing x. So we got 8 minus -2 over negative 3 minus 9, which is 10 over negative 12, which is negative 5 over 6. Now we got the point passing through, we got the gradient, we can calculate the perpendicular bisector equation. So we know that the gradient of a perpendicular line is the negative reciprocal, so we have y equals 6 over 5x plus c. Now we know it passes through 3, 3. So when we plug in 3, we'll get 3. So 3 equals 6 over 5 times 3 plus c. c is negative 3 over 5. Drawing this on the graph properly will be something like this, where the y-intercept is negative 3 over 5. And that's it for today. Thank you for watching.